Today's lesson is on identity matrices and inverse matrices. I realize I left out the target, so you might want to take a minute to think about what the target is. I can use inverse matrices and identity matrices to solve systems of equations. So that's what we're getting down to, is how to do these things, how to use these things, how are they helpful? Why do we care about matrices? And so part of it is that we can solve systems of equations, quite complex systems of equations, if we know how to do matrices. First of all, what about inverse matrices? What does that even mean? And what is an identity matrix and all that? Remember that the identity is 0. What does that mean? Well, 0 added to anything does not change the identity of the original item. So 5 plus 0 is still 5, and negative 8 plus 0 is still negative 8. We also have an additive inverse. So sticking with addition, 5 and negative 5 are additive inverses because 5 plus negative 5 is 0. So that makes it an additive inverse. All of these phrases are things that you probably learned in middle and probably even elementary school, but they might not have had much meaning, honestly. Multiplicative identity is 1 because 1 times anything is itself. Just like 0 plus anything is itself, 1 times anything is itself. And so why is that helpful? What do we need with it? Well, when we're solving equations and things, well, let's talk about multiplicative inverses. When we have a multiplicative inverse, 2 times 1/2 is 1. They are multiplicative inverses. They are inverses of each other. You multiply 2 times 1/2 and that gives you 1. Or negative 1/10 times a negative 10 is going to give you 1. So inverses, 2 and 1/2 are inverses. Negative 1/10 and negative 10 are inverses. Because when you multiply them together, you get 1. And 1 is the identity. All right, well, what about matrices? We have identities with matrices as well. And we also have inverses with identities. The matrix identity, and what does it do? And I just decided to put these together because it just makes more sense. If you multiply the identity matrix times another matrix, you get the original matrix. So it's kind of like multiplying by 1, but it's not scalar multiplication, it is matrix multiplication. So a matrix inverse is if you multiply the inverse matrix times the original matrix, you get 1. Well, how do you find the inverse matrix? We're going to talk about that. We're going to talk about how to find the identity matrix as well. Some examples of the identity matrix. The identity matrix is basically any matrix, that should be straighter, any matrix which has these ones that go from the upper left corner to the lower right corner. So you have zeros all throughout, except there's a 1 going down from the upper left down to the lower right. That's a 3 by 3. Here's one that is a 4 by 4. Okay, so we have a bunch of zeros, but then we have 1s going down from the upper left all the way down to the lower right. Those are an identity matrix. What does that mean? It means if you multiply this matrix times another matrix, it won't change the identity. It keeps the same matrix when you do that, just like multiplying times 1. Well, how do we do this? Well, of course, your calculator can do it for you. Yes, there are ways to figure out how to do it, but we've already decided that that is pretty complex, so let's just talk about how to do it on the calculator. Here are the instructions. Let's see if you can do this one. I've given you the answer here, but take a second to enter this matrix into your calculator, and we're going to talk about how this becomes the matrix. So go ahead and enter that into your calculator, pause the video if you need to, and then we'll talk about if this is the matrix. Okay, hopefully you've gotten this into your calculator now. So you enter the matrix, and then to find the inverse matrix, you do this button, this x to the negative 1 button. X to the negative 1 works with numbers, and it works with these inverses. It just means 1 over. So for instance, in your calculator, if you typed in a 3 and then you typed in this x to the negative 1 button, it would give you 1/3 or 0.33 repeating. If you typed in a 5 and then you typed in the x to the negative 1 button, it would give you 1/5 it would probably give it to you as a decimal, which is 0.2. That is what that button does. It gives you the reciprocal. With regular numbers, we call that the reciprocal. You want to write that down, you can. That's the reciprocal. With a matrix, now we type in a to the negative 1, and when we type in a to the negative 1, we get this as the answer. Make sure you got this as the answer. This other one, we can do that at a later time. We can practice in class if we need to. Make sure you just understand how to get the inverse matrix. Okay, why is it useful? Well, to solve equations. Think about when we solve equations, and for instance, I just mentioned the word reciprocal, right? Well, let's say you had an equation and you had, a really basic equation like 2x equals 8. Well, one thing you would do is you could multiply this side by 1/2 and multiply this side 1/2. The reason you're doing that is those are multiplicative inverses. And the multiplicative inverse cancels it out and leaves you with a 1. And over here you're going to have 4, obviously. So that's what the multiplicative inverse does. And the same thing will work for matrices. It's going to look different because instead of getting a 1, what do we get? Well, we get this matrix that has all these zeros and 1 in it. But that's helpful to us because that is essentially like a 1, and so that's what we need sometimes. So let's take a look at what we mean. Let's say you have this equation. Take a second right now, and before we get started on it, we're going to call this matrix A, and we're going to call this matrix B. Enter both of those, matrix A and matrix B, into your calculator right now. Go ahead and pause the video. Okay, now that you have entered matrix A and matrix B into your calculator, now what I want you to do is find, and I think I'm going to change colors here, is find a to the negative 1 power. So you go matrix A and then x to the negative 1, and when you find a to the negative 1, see what your calculator gives you. It should give you 0, 0.2, 0.3 repeating, and 0.13 with the 3 repeating. That should be your a to the negative 1. That is the inverse of matrix A. So what we want to do now is we want to multiply both sides by that matrix. And on your calculator, hopefully you understand how to do sort of a cut and paste on your calculator. We can take a look at that in just a second if we need to. But right now you're going to multiply both sides by this matrix. Just like how you solve equations when you multiply both sides times 5 or multiply both sides times 1/2. Okay, we multiply this on both sides. What that does is that gives us the identity matrix over here times x, which is a matrix, and set that equal to, and we multiply it over here, and it gives us 0, 3, 1, 2. Let's take a second to look at your calculator and make sure you understand how to multiply that. Okay, let me show you how to use your new matrix. When you found the inverse of A, now mine's called C on my screen, but it really is the inverse of A. When I do that, I get this matrix, 0, 0.2, 0.3 repeating, and negative 0.13 repeating. Now, if I want to multiply that times matrix B, all I have to do is leave that on your screen, and if you just hit times, and now it says answer times. That means it's going to take that matrix and multiply it times whatever you say to multiply it by. We want to multiply it by matrix B. I hit this times second matrix, and then if you hit names, but don't hit anything yet, you want to go down to what you want to go to, so you want to choose matrix B and hit enter, and it'll multiply it by it for you. I added mine into D, so I'm going to go down to D, but yours is in B, so go ahead and multiply it. So you have the answer from before times B. Mine says D because I entered a different place, and if I hit enter, then now I have my answer matrix. That is the answer of question number 3. Question number 3 was asking basically what does x equal? Well, x is a matrix, and that matrix is equal to 0, 3, 1, 2. That is the answer matrix. Once again, we are going to skip number 4. We can possibly do that in class if we need to. Let's move on to the other side of the page. Okay, this comes out of our textbook, and I will tell you that our textbook, this actually isn't in your textbook, of course. I know it's been hard to get things wrapped together this year, but this textbook has it in like an addendum. So that's where this is coming from. The point is we can use matrices to solve systems of equations. Solving a system with 2 variables by now is really easy for you guys because you're up to 3 variables and you know how to do that. But the fact is we could get to 4, 5, 6 variables and we would use our calculator with matrices to solve them. Here's what we're going to do. We're going to rewrite this system as a matrix, and we're going to make it into the form A times X equals B, just like we were doing a minute ago. We're going to name our coefficient matrix first. So this is our coefficient matrix. If we look at the coefficients, we have 2, 5, 1, and 3. So that's what I have in my coefficient matrix. That's matrix A. Now I also have what I'm going to call the variable matrix, and we can just call that X. And we're going to set that equal to the constants, that is the numbers on the right. So we have a 3 and a 2 over here. We're going to put a 3 and the 2 over here. Our next step is to find the inverse of A. So we're going to find A to the negative 1 power. So pause it for a second. Put in this matrix, 2, 5, 1, 3, into your matrices. Now that you have put 2, 5, 1, and 3 into your matrices, now you want to hit the, well, it's not the A to the negative 1 button, it's the X to the negative 1 button. And when you hit that X to the negative 1 button, you should get 3, negative 5, 1, and 2. That is your inverse matrix. That is your A to the negative 1 power. And again, the reason for that is what we were just doing a second ago. That's going to help us solve an equation. Here we have basically an equation. This is going to help us solve this equation. Because now what we're going to do is we're going to multiply that matrix of constants by A to the negative 1 on the left. So we're going to multiply this side times A to the negative 1, and we're going to multiply this side, which was matrix B, times A to the negative 1. And so on our calculator, we'll type in names B, and then we'll say times, and then we'll say names A, and then we'll do the X to the negative 1 button. So you put that in there and you see what you get. Well, basically what we originally had was our matrix A and our matrix X, and we set that equal to matrix B, and we are solving for X. So if we multiply this side times A to the negative 1 power, and we multiply this side times A to the negative 1 power, what that's going to do is cancel out the A matrix and leave us with the X matrix. And our X matrix, remember, is just X and Y. And when you hit B times A to the negative 1, you should get negative 1, 1. What that means is, that means X is negative 1 and Y is negative 1. Why would we do that? Well, basically, it is just a different way of solving this system. So if you hate substitution and elimination and you'd rather never do it again, well, guess what? You can do this instead. Personally, I think with a 2-variable system, it's a lot easier just to solve it. But some people really don't like that. But mainly, we could get to, like I said before, we could get to 3-variable, 4-variable, 5-variable, etc., and we could solve them with matrices, which would be much, much easier, I think you can see, than trying to solve them by hand. Because we already had enough trouble solving our 3 variables by hand, but it could get even more complex. So by doing what we've done, we come up with this solution on our calculator. That is how we involve matrices, and we look at the identity matrix, and we can use all of that to come up with a solution to equations.